Most of us have heard of the Bermuda Triangle. But what if it had an older, darker twin? A place in the Pacific where ships vanished, aircraft disappeared, and ancient legends spoke of a fire-breathing dragon beneath the waves. Then came the modern age. One ship was nearly 300 meters long, larger than the Titanic, and equipped with sophisticated navigation systems. Yet it disappeared. No distress call, no wreckage, nothing. So what is actually hiding beneath this part of the Pacific? Because the answer may be far more terrifying than a sea monster. Locating this threat on a map is the first challenge. Unlike designated shipping lanes, these waters south and southeast of Japan exist largely as a cultural shadow. Depending on who you ask, this region is known as the Dragon's Triangle, the Devil's Sea, the Sea of Troubles, the Pacific Bermuda Triangle, or the Formosa Triangle. Scientists recognize no official coordinates here. No government agency marks its borders. Instead, competing accounts stretch the boundaries across the vast Izu-Bonin volcanic ridge and far into the Philippine Sea, expanding or contracting to fit the latest maritime tragedy. Something disappeared here. And this geographic uncertainty only sharpens the divide between those who believe an ancient supernatural force controls these waters and those who suspect the real danger is entirely explainable. Ultimately, it is a choice between ancient mythology and the harsh laws of physical reality. In the autumn of 1274, Kublai Khan launched an armada of up to 900 ships from Goryeo, carrying over 20,000 warriors to conquer Japan. The invasion faltered against fierce Japanese resistance and logistical strain at Hakata Bay, before a sudden gale wrecked a third of the Mongol fleet. 7 years later, the Khan returned with an even grander force, more than 4,000 vessels and nearly 140,000 men. This time, Japanese defenders stood behind a 20-kilometer stone wall, pinning the invaders to their ships. Then, on August 15, 1281, a second violent storm devastated the trapped armada. To the surviving Japanese, these timely tempests were kamikaze, the divine winds sent by the gods. But science offers a different verdict. Sediment layers extracted from coastal Kyushu lagoons reveal two massive storm surges from the late 13th century. The legendary divine winds were actually powerful climate-driven typhoons. The modern legend of these waters took shape centuries later, codified not by mariners, but by an author. In 1974, Charles Berlitz popularized the Bermuda Triangle, framing a patch of the Atlantic as a zone of inexplicable terror. In 1989, he extended this lucrative template to the Pacific. His book, The Dragon's Triangle, drew lines across the Philippine Sea, imposing a precise geometric boundary over a vast ocean. Within this perimeter, Berlitz grouped decades of unrelated maritime disappearances, weaving them into a single pattern of mysterious forces and atmospheric vortices. This raises a fundamental question. Did a genuine anomaly exist in these waters? Or did a memorable story simply select and rearrange real tragedies to construct a mystery? On September 23, 1952, the Japanese oceanographic survey vessel Kaio Maru No. 5 slipped out of Tokyo Harbor. Its destination lay 300 kilometers south, along the volatile Izu-Bonin volcanic ridge. Reports had reached the mainland of dramatic undersea activity near the Bayonnaise Rocks, where a newly formed volcanic island named Myojin-sho was rising and collapsing within the waves. This highly specialized scientific expedition carried 31 people, 22 experienced crew members, and 9 marine scientists. Their objective was to map the seabed, analyze water samples, and observe the unstable marine environment surrounding the active vent. For the team aboard, the voyage represented a vital step in understanding the undersea forces shaping their home archipelago. By September 24, the ship reached the coordinates of the boiling caldera. Then, the transmissions stopped. No distress call was sent. No radio operator reported trouble. A modern research vessel and 31 lives vanished from the naval tracking grids, leaving no immediate explanation. For the families waiting on the mainland, the silence was absolute. The ocean offered no clues, leaving only an empty expanse of water where a ship had been navigating just hours before. 5 years later, the silence returned, shifting from the sea surface to the skies above. On March 22, 1957, a United States Air Force C-97 Stratofreighter departed on a routine trans-Pacific flight. Boarding the massive military transport were 67 passengers and crew, flying toward Yokota Air Base. The flight proceeded normally until the aircraft reached a position roughly 320 kilometers east of the Japanese coast. Under a darkening canopy of severe Pacific weather, the pilots checked in. It was a standard, unremarkable radio transmission. Then, the signal cut out. A massive search operation immediately mobilized, scouring more than 140,000 square kilometers of ocean. Ships and aircraft combed the cold waters for 8 days, looking for oil slicks, debris, or life rafts. They found nothing. No wreckage ever drifted ashore, and no physical trace of the 67 souls was ever recovered. The military was forced to close the file, leaving the official cause unresolved. The flight had simply crossed into the gray weather off the coast and vanished. The sheer size of a vessel often creates an illusion of invulnerability. In September 1980, the bulk carrier MV Derbyshire challenged that assumption. She was a colossus. At nearly 300 meters long, the vessel was larger than the Titanic, built with double-hulled steel and equipped with the most advanced navigation systems of her era. On her final voyage, she carried 160,000 tons of iron ore from Canada to Japan. But as she neared her destination, she sailed directly into the path of Typhoon Orchid. The storm was monstrous. It generated Force 11 conditions, whipping up 30-foot waves that pounded the ship's massive frame. Yet, the Derbyshire was built to withstand the worst the oceans could offer. Her crew of 44, including 2 wives of the mariners, relied on her immense size and modern technology to see them through. Then, the radio went silent. There was no distress call, no automated alarm. A ship twice the size of the Titanic simply vanished from the tracking screens. For 14 years, the families of the crew lived with an agonizing vacuum, left with no wreckage, no answers, and only the dark folklore of the Devil's Sea to fill the void. The silence broke in 1994. A specialized search team located the shattered remains of the Derbyshire resting in the absolute darkness of the ocean floor, 4,280 meters down. The scale of the devastation was immense. The giant ship lay in thousands of pieces, scattered across the abyssal plain. Finding the hull was only the beginning. The condition of the wreckage would hand the mystery over to forensic oceanographers, who had to reconstruct the final violent moments of a Titan. Then came the evidence. No witnesses survived the destruction near the Bayonnaise rocks, but the ocean recorded the event. Far to the east, naval hydrophones captured the low-frequency acoustic rumble of a massive underwater explosion. Simultaneously, a tide gauge on Hachijo-jima registered a sudden, localized 2-meter tsunami. When search teams combed the area, they recovered shattered fragments of the vessel. Trapped inside the torn wood and vinyl were freshly cooled, lava-covered rock fragments. These pieces do not build an absolute reconstruction of the final seconds, but they provide measurable proof. The vessel was not taken by a supernatural void. It was positioned directly over an active submarine volcano when the seafloor fractured, unleashing a violent eruption that instantly overwhelmed the ship. Meteorological records from that night reveal a chaotic sky. Nearby flights reported severe turbulence, active lightning, and winds approaching typhoon strength. In such extreme convective conditions, an aircraft faces immediate, compounding hazards: heavy structural icing, sudden loss of control, and spatial disorientation. Because no physical wreckage was recovered, investigators could not issue a definitive verdict, leaving the official record unresolved. Yet, unresolved does not mean extraordinary. While a precise cause remains out of reach, the meteorological data presents severe weather as the most plausible explanation. The plane likely met a violent, natural end, overwhelmed by the storm. Forensic analysis of the Derbyshire wreck revealed exactly how the Titan fell. Extreme wave impact shattered the bow, shearing away the forward hatch covers. Ocean water poured into the forward cargo holds, destroying the vessel's stability in moments. It was a rapid, physical failure driven by storm force waves and flooding. This reliance on physical data is what drove the work of researcher Larry Couchet. While Charles Berlitz framed these losses as supernatural occurrences, Couchet spent years examining original ship logs, weather records, and official accident files. By verifying exact locations, dates, and archives, he proved that real tragedies are transformed into supernatural myths only when actual causes are omitted and uncertainty is amplified. His critique remains a warning against sensationalized storytelling. The legend of the Bermuda Triangle is a manufactured mystery. It is based on faulty logic, inaccurate reporting, and the repetition of errors. Behind the folklore of the Devil's Sea lies a violent geological reality. This region sits directly on the Pacific Ring of Fire, a volatile tectonic belt where plates collide to carve out massive seafloor trenches and fuel the Izubonin volcanic arc. Far beneath the waves, submarine volcanoes erupt in the darkness, displacing immense volumes of seawater while releasing heat, toxic gases, and ash. The raw scale of these underwater events is difficult to comprehend. In 2009, oceanographers recorded the active eruption of the West Mata volcano, operating under extreme pressure nearly 1,200 meters down. 10 years later, a major eruption near Tonga unleashed a massive pumice raft that covered hundreds of square miles of the ocean surface. While these geological events cannot be blamed for every maritime tragedy, they show that the Pacific is a highly active, unpredictable engine. But the geological forces below are only half of the Pacific's engine. Above the surface, the atmosphere builds a different kind of monster. It begins with the water itself. When the ocean surface warms to 26 degrees Celsius or higher, it fuels massive evaporation. Warm, wet air rises rapidly into the sky. As this rising vapor cools, it condenses into clouds, releasing vast amounts of latent heat back into the atmosphere. This sudden release of thermal energy acts like supercharged fuel, accelerating the updrafts and causing surface air pressure to plummet. To fill this deepening vacuum, surrounding winds rush inward, organized into a violent, spinning vortex by the Coriolis effect. This is the birth of a typhoon. Once formed, this atmospheric engine translates directly into brutal maritime consequences. The immense energy of the storm whips the sea into chaos, generating blinding rain, zero visibility fog, and extreme waves. For any vessel or aircraft caught in its path, the physical forces are absolute. 90-mile-an-hour winds generate massive waves that can easily fracture a steel bow or shatter structural hatch covers. Once these openings are overwhelmed, thousands of tons of ocean water pour into the interior. Stability vanishes in seconds, pulling even the largest structures down into the deep. This single atmospheric mechanism unites the region's historical tragedies. It is the same relentless force that scattered the ancient wooden warships of the Great Khan, tore through the flight path of the military transport plane, and violently dismantled the steel hull of the modern bulk carrier. While science cannot offer absolute certainty for every cold case, these recurring typhoons and the extreme waves they breed remain the single strongest explanation for the losses. The Kuroshio Current flows along the coast of Japan, its core reaching speeds of 2.5 meters per second. This immense movement of water extends deep below the surface, shifting continuously through unpredictable eddies and changing paths. These changing ocean temperatures and currents make the Pacific highly turbulent, constantly complicating navigation, throwing off drift calculations during rescue operations, and making the search for sunken wrecks incredibly difficult. Deep below this moving water lies another physical process: methane hydrates. These are vast reserves of natural gas trapped inside ice-like structures within the marine sediments. In theory, a sudden thermal shift or geological disturbance could destabilize these deposits, releasing massive plumes of underwater bubbles. As these bubbles ascend, they reduce the density of the surrounding seawater, potentially compromising a vessel's buoyancy in seconds. But a clear line separates physical possibility from actual history. While laboratory experiments and theoretical work show how this mechanism works, no physical evidence connects a methane release to any documented loss in these waters. It remains a possible physical mechanism, not a proven cause. When the legends are stripped away, a clear hierarchy of evidence remains. Submarine volcanism is the strongest explanation for the geological traces at the Bayonnaise rocks. Severe weather remains the most plausible cause for the unrecovered aircraft, while storm-driven waves and flooding are physically proven by the recovered wreck. No evidence supports dragons, aliens, or supernatural forces. Scientifically, there is no proof these waters are unusually dangerous. Modern shipping loss statistics do not place the region among the world's most hazardous oceans. The true tragedies here belong to physics, and to the families of those lost to the extraordinary power of the Pacific. These ancient myths are not dead ends. They are invitations to look closer. When a vessel vanishes without a trace, we blame the supernatural because the alternative forces us to confront our own insignificance. The reality is that more than 99.99% of the global seafloor has never been visually seen by human eyes. Wreckage is not lost to another world, but hidden by extreme depth, shifting currents, and immense distance. The legendary monster was never a dragon, but the extraordinary power of the Pacific itself. The real mystery is not a supernatural monster. It is how little we still understand about the ocean. Today, we map distant stars, while our own oceans remain a dark, uncharted frontier. Every ship that sets sail still crosses an abyss we barely comprehend. The true monster was never a dragon. It is the raw, indifferent power of the Pacific, and the terrifying reality that we are still just skimming the surface of a world we do not control.